Algebra 1 students, welcome back. Here are your notes from section 2.2 for you to look at this weekend. And then you can come to class Monday prepared to answer some questions and do an assignment over this topic. First things first, a little review from 2.1. Inverse operations. An inverse operation is an operation that undoes something else. Now we talked about this already, but the inverse of addition is subtraction. Where the inverse of subtraction is addition. The key being that those two operations undo each other. Now for multiplication and division, they have a similar relationship. Division undoes multiplication, where multiplication undoes division. Let's do some examples where we work with this. Although I should highlight one part of this that I've skipped over a little bit. It says we undo operations in the reverse order of operations. Whereas when you look at example 1, multiplication comes before division when we follow order of operations. In this particular case, we need to do the opposite. So we'll subtract 5 from each side. That's our subtraction property of equality. We'll have 3x equal to 15. Now in order to undo that multiplication, 3 times x, we need to divide by 3. And we'll find our solution, x equal to 5. Up next on number 2, you can see we have x divided by 4 minus 2 equals 8. So my first step is going to be to undo the subtraction. We will add 2 to each side. X divided by 4 then would equal 8 plus 2, or 10. And in order to get x by itself, I need to multiply by 4 on both sides, and I'd have x equal to 40. Why don't you pause the video right here, work through the next 2 problems on your own. Okay, welcome back. I'll walk through these just to show you what hopefully you came up with. In this particular problem, we would need to start by subtracting 6. So we'd have a negative x equals 9 minus 6, or 3, and then divide by negative 1. And that gives us x equal to negative 3. Now some of you may be asking, Mr. Hale, where did that negative 1 come from? So just as a little reminder, I want to remind you that negative x is the same as writing negative 1x. Typically when we have a 1 as a coefficient, we don't actually write it in front of the variable. It's just implied. Math people, go figure. All right, number 4. On this one, you might be tempted to deal with this addition, since I said to follow the reverse of the order of operations. However, this bar right here is actually a grouping symbol. So we need to deal with the 3, see if I can write that legibly. We need to deal with the 3 before we move on to deal with the plus 5. So we'll multiply both sides of the equation by 3. That undoes the division. So x plus 5, of course, would be 30. Then we can use our subtraction property of equality. And we end up with x equal to 25. We now have a couple of application problems to look at. Let's do these one at a time. First, number 5. Susie has $26 and a coupon for $2 off at Best Buy. The CD costs $3. Must be on sale this week. How many CDs can she buy? Well, the question is asking us how many CDs we can buy. So that would represent our variable. X would be the number of CDs. We know that each CD costs $3, so we can do 3 times x. That would be our total cost on CDs. However, there is a coupon that Susie has found that saves her $2. So we'll subtract that from her total cost. And again, as we said earlier, she can spend as much as $26. All right, now we have a little equation to solve. We'll add 2 to both sides. So 3x is equal to 28. As you have probably noticed, as I've worked through all these problems today, I've been showing every step of my work. I hope as you work on your assignments that you'll do the same thing and develop these same habits. Even here I ran out of space, so I just rewrote it. Not a big deal. It only takes a few seconds. All right, so we have 3x equals 28. Let's divide both sides by 3. Now this is the time where it's not going to come out all nice and pretty. However, 3 times 9 is 27, so that leaves us with just a remainder of 1. We'll put that over 3. X is 9 and 1/3. Very few stores sell 1/3 of a CD. So we will only be able to purchase, or rather Susie will be able to purchase 9 CDs. All right, on the next one, Frank is going bowling. The shoe rental is going to cost him $3, and then each game that he bowls will be $2.50. He has as much as $12 that he can spend. How many games could Frank bowl? Okay, well, again, we have to define a variable. Let's start by doing that. And the variable represents the unknown in the problem. In this case, it's how many games is Frank going to bowl. So X represents the number of games bowled. The problem states that it costs $2.50 for every game that he bowls, and there's an additional fee of $3 that he just has to pay once for his shoes. And we also know he can spend up to $12 total. So our equation looks like that. Let's go ahead and solve. We'll subtract 3, and I'm going to write my answer up over here. 2.50x is equal to 9. A little division will undo that multiplication. And this is another one that doesn't work out nice and pretty. So what I have is 3 times 250 would give me 750. So it's 3, and I would have $1.50 left. So I'm going to go ahead and write it as some weird fraction mixed with decimals that you don't want to simplify necessarily. But the good news on this problem is we don't have to. All we have to do is say, well, how many games can Frank afford? Well, Frank can bowl 3 games. One last topic for us to look at is actually the beginnings of something that we call algebraic proof that you'll study next year in your geometry classes. And it's essentially saying solve the equations, but then on each step, explain the reasoning. So we'll do that. Even on the first step, which may seem kind of weird, but it's the simplest one, it's always the same answer. It's the given problem. Okay, so we'll put our justifications over here on the right, and we'll work the algebra over on the left. You guys have seen these steps before. We add 7 to both sides. The difference is when I get to this point right here, I need to explain why I was able to do that. How did I go from step 1, that I'm calling step 1 here, down to step 2 down here? The reason was we were able to add to both sides. That's called the addition property of equality. So in other words, we kept the equation with the same value. We just added 7 to both sides to get rid of one portion of it. We're going to do the same thing on the next step. Let's divide both sides by 3. And that'll give us x equals 7. Now I would call that step 3. And the reason we know that x equals 7, if 3x equals 21, is because we're dividing. So this is the division property of equality. All right, one more example. 11 equals 4 plus x plus 5. As I mentioned before, we can just start by explaining that that's the given problem, and then we start doing our work. To get x by itself, I first need to subtract 4 from each side. And again, remember, you have to explain your logic on each step. So for this step, the reason I could get from the beginning problem to 7 equals x over 5 was the subtraction property of equality. We have one more step remaining. In order to undo this division of x divided by 5, I need to multiply both sides by 5. I'm going to do a little color coding there so you can tell that wasn't part of the problem originally. X over 5 times 5 is just simply x, and of course 5 times 7 is 35. And what we used there was the multiplication property of equality. All right, folks, you have finished the 2-2 notes for today. Your next job is to look just below this video on the site, and there's a link with some questions for you to answer. It won't take you very long at all. Give me honest answers. Tell me if you ran into any technical problems or any other issues that you may have run into. I hope you guys have a fabulous weekend, and we will see you Monday so we can get some work done.